We've already talked about a system of equations and how to solve systems of equations algebraically and through graphing, but we now need to talk about solving a system of inequalities. And the only way to solve a system of inequalities is by graphing. So when we had a system of equations, our solution was the point where two lines intersected right here. As you know, when we have a system of inequalities, a system made of inequalities, when I graph an inequality, I end up with one side of a line that's shaded. If I graph two inequalities on the same coordinate plane, I'll end up with two lines that have shading. And the solution to the system is that region where the shading overlaps. So the solution is where you have double shading. So to solve the system of inequalities, we're going to need to graph a system. So the first thing I want to do is I am going to come up with a system. So our first example is going to be y is greater than 4x minus 3, y is greater than or equal to negative 2x plus 3. So I want to graph both of these inequalities on the same coordinate plane. And I'm just going to take a moment to grab a pencil because I find that using a pencil on these for the shading is much more effective. So what I want to do first is graph my first line, y equals 4x minus 3, so that's the relative equation, so I'll start with negative 3, and my slope is 4, so I'm going to go up 4 and over 1. This is a greater than, so I am going to have a dashed line, not a solid line, because we don't have the equal to portion. And now I need to determine which side of this line I should shade. So I'm going to pick the point 0, 0, plug it in, and I'll get 0 is greater than 0 minus 3, or 0 is greater than negative 3. That is true, so I need to shade this side of the line. And what I'll do is I'll come in with a pencil and I will shade very lightly. I'm not sure if that's showing up very well in the video, but as you can see I did shade very lightly. Then I graph the second line. Y is greater than or equal to negative 2x plus 3, so I'll start at positive 3. And since I have a negative 2, I'll go down 2 and over 1. And this is a greater than or equal to, so I can draw a solid line. And then I need to determine which side of that line I need to shade. So I'm going to pick the point 0, 0 again because it's also not on the second line. And if I plug that in, I get 0 is greater than or equal to 3. And that is a false statement. So I don't shade this side of the line, I shade the other side of the line. So I'll come and I will shade this side lightly. And then between the two shadings, because I shaded this section here twice, it's slightly darker. This is my solution area. So I'll come in and I'll make sure to shade that darker so that it's very obvious that this is the region that is true for both inequalities, and therefore this is the region that is the solution to the system. Let's try another one. I'm going to use the line greater than or equal to x minus 3. Y is less than or equal to negative 1/2 x plus 2. Okay, so I'll make my coordinate plane. And now you don't have to do this, but if it makes it easier so that you'll know the boundaries of where you want to shade, you can box in your coordinate plane so that you're not shading, the whole page. Okay, I'll start with my first one. Y is greater than or equal to x minus 3, so I start at negative 3. X has no coefficient on it, so that means that my slope is a 1, so I go up 1 over 1. And this is a solid line because I have an or equal to, so I will come through and I'll draw that solid line. Okay. Now I'm going to show you an alternate way to shading the whole thing on the next couple of examples, but for this example I'm going to go ahead and do the full shading. If I plug in a 0, because that point is right there and it's not on the line, I get 0 is greater than or equal to negative 3, and that is true, so I'll need to shade this whole section here lightly. Okay. Next, I'm going to graph the second line. Y is less than or equal to negative 1/2 x plus 2. So I start at 2, and I'm going to go down 1 and over 2. This also has and or equal to, so I can graph this line with a solid line. And when I plug in the point 0, 0, because it's not on the line, so I'm allowed to, I get 0 is less than or equal to 2, which is true. So I need to shade this side of that line. And as you can see, this area is where the shading overlapped, so I come in and I make that darker. Like so. Now again, if you don't want to do all of that shading for whatever reason, I have an alternative method. So let me just write down two more equations. We'll have 4x minus 3y is less than 9, and x plus 3y is greater than or equal to 6. These are going to need to be put into the y equals mx plus b format first, but I'm going to go ahead and draw my coordinate plane. Okay, so 4x minus 3y is less than 9. Moving the x over, I get negative 3y is less than negative 4x plus 9. Dividing everything by negative 3, I get y is less, oh, sorry, I divided by negative. I have to flip that. Y is greater than 4/3 x minus 3. Don't forget to flip when you divide by negative. Then on the other example, I have x plus 3y is greater than or equal to 6. Moving my x, I get 3y is greater than or equal to negative x plus 6. I divide everything by a positive 3, and I get y is greater than or equal to negative 1/3 x plus 2. So I'll graph each of these lines. I start with my negative 3, and my slope is 4/3, so I'm going to go up 4 and over 3. This is a greater than, so I need a dashed line. And I need to plug in 0, 0 because that's not on the line. Actually, you can plug in any point, but 0, 0 is nice because it makes the variables all go away. And I get 0 is greater than negative 3, and that's true. So now, if you didn't want to shade the whole thing, you can draw lines to indicate that this is the side that would be shaded. come in and we'll graph our other equation. So we'll start at positive 2, and our slope is negative 1/3, so I'll go down 1 and over 3. This one gives me a solid line because of the greater than or equal to. And then I plug in 0, 0 again because it's not on the line, so I can. And I get 0 is greater than or equal to 2, and this is false. So I don't want to shade this side, I want to shade that side. So then what I do is I come in, here I had drawn horizontal lines, so now I will draw vertical lines. And you don't have to do these in 2 different colors, I'm just doing 2 colors to make it obvious of what I'm doing. Now the area where you got both horizontal and vertical lines, this is your solution area. So that is the area that you will want to color in completely or shade completely. So I'm going to come in and shade this region because this is my solution region. And that is how you solve and graph systems of inequalities.